Hello and welcome to section 4.7. In this section we're going to talk about inverse trig functions, and the first question here just says, does sine of x have an inverse? And the way this function is written, it does not. And the reason why is, if you remember from when we were doing this before, if we were trying to determine if something was a function, we did what we called a vertical line test. And you'll notice that sine is a function because it passes the vertical line test, meaning if I draw a vertical line anywhere in the function, anywhere in the graph, and it only crosses one particular point, it's a function. Well, there is also, to figure out if a function has an inverse, is what we call a horizontal line test. So if I was to draw a horizontal line, something like this, and if, just like in the vertical line test, if the horizontal line crosses the function at more than one point, then there is no inverse for this function as it is written. So what we're basically looking for is, if I was going to do an inverse of this, and it's just talking about if I wanted to invert this, then the function itself would look something like this. And then here you can see that by doing a vertical line test, which is what we normally do to test if it's a function, you can see that the inverse of sine is not a function because it doesn't pass the vertical line test. But the reason that we're saying that sine does not have an inverse as it is written is because it does not pass the horizontal line test. So could I fix it so that this function has an inverse? Yes, I can. And here's the graph that would do it. I would have to restrict the graph so that it's all positive. Think about our unit circle. So we're going to go from negative pi over 2 to pi over 2. And so this would get me the inverse of my sine function, and this is basically the fourth quadrant and the first quadrant in our unit circle that we would restrict this to, so that we could guarantee that we have an inverse. And that's really what's going to happen for these trig functions, is that we're going to have to do some restrictions to get them to have inverses. So this next slide is basically the definition of the inverse of sine. And so you need to know that inverse of sine, as it is written on your calculator, is like this: sine to the negative 1 of x. Also, kind of the old school way is arc sine. And we use arc sine in calculus more than we use the inverse sine, but you need to know that these two are kind of interchangeable. So here's the definition: if and only if sine of y equals x between negative 1 and 1, and here's our domain restriction. Is basically that we're talking that it's between negative pi over 2 and pi over 2, and this will then restrict it so that when we're talking about this, that sine, remember sine is our y values, that we're restricting this thing to the first and second quadrant, and it will basically give us the inverse trig function that we're dealing with. All right, and so y is the angle whose sine is equal to x. And so that's really all we're talking about for our inverse. So now we're going to graph this function and kind of talk about what the arc sine is. Remember that this is the same as what I have down here, x equals sine of y. So I'm asking you basically what is the if this is my y value, I'm plugging it in to find my x value. And so if I have negative pi over 2 from my unit circle, I get negative 1. If I put in negative pi over 4, I get from my unit, all of these are from my unit circle. At pi over 6, I'm at negative 1/2. I'm at 0. I'm at positive 1/2, root 2 over 2, and this one is positive 1. So then when I go to graph these things, I have to remember that this column right here, the red one, is really my x value, and over here is my y value. So when you see me graph these, that's what I'm going to do. So when I'm at negative 1, I am down here at negative pi over 2. And I kind of stretched my graph out because these would be really tight if I did them the other way. At negative pi over 4, I'm at negative root 2 over 2, which is my x value. So negative root 2 over 2 is just a little less than 1. And so when I'm at pi over 4, it's going to be about right here, I would say. And then when I'm at pi over 6, we'll say this is pi over 6, and it looks like we're at negative 1/2, so right in the middle here at pi over 6. And then at 0, I'm there, and so then the function will continue. At 1/2, I'm right there, and then at a little bit under 1, I'm at pi over 4. oops, it should be right there, sorry, put my dot in the wrong spot, and then at, should be right about there, and then at 1 I'm at pi over 2. So you can kind of see the graph makes this kind of S shape, and so this is the restriction, and this is the same part of sine that we were dealing with before, but this right here is our arcsine function. So this is what you need to kind of think about and remember when we're doing these. And so then we talk about, well, what do we need to do to restrict the domain of the cosine? Well, cosine, we need to restrict it so that we can end up with our function being so we can be between -1 and 1 for our domain, and basically we want to do from the top to the bottom of cosine. And if you remember cosine itself, we went from the top up here down to the bottom, so we need to think about, well, this is 0, and to get to the bottom down here, this is pi, so that is our domain restriction that we're going to use. So we're just trying to get half a cycle so that this thing becomes the inverse function. If we go beyond this, then we start ending up with failing the horizontal line test. So that's the whole idea, and they just kind of restricted it so that we can do a horizontal line test and get more than one, get that there is an inverse. And then how would we restrict tangent? Well, tangent is going to be between asymptote and asymptote, and so if you remember, the asymptotes of tangent are the same as what we're restricting sine to, so we end up doing something like this as our restriction for tangent. So if you have any questions about these things, please come to class prepared to ask them, and we'll talk more about this in class.